Welcome to Mastering Solutions. And so we have our two mirrors here that are parallel to each other. And the whole length of the mirror on the bottom is 40 centimeters. And the height of it, of course, is the 8 centimeters. And so we need to figure out, as this light comes up here, it's going to be reflected off and it's going to continue on, and it's going to have the same angle since these two mirrors are parallel to each other. So this one would also be 60 degrees and so on. If you look at it, we have a triangle right here, a right triangle. And so if we have this is the mirror, this is the height of the tube, and then this is the 60 degrees right there. And so this would be 8 centimeters or 8 times 10 to the negative 2 meters. And then down here, this is x, and we don't know what that is. And so the hypotenuse, we don't really care what that is because that doesn't matter for us to figure out how many times it bounces. In order for us to figure out how many times it bounces, the x, that's what's most important, because we're going to have one x here, we'll have another length x there, and so on as it goes down. So we need to figure out how many x's there are along this whole tube length. And so we can use some trigonometry to solve for x, and we can use tangent. So we know the opposite of the angle is the 8 centimeters and the adjacent is x. So tangent of theta is equal to the opposite over adjacent. So tangent of 60 is going to be the 8 centimeters over x. And so if we multiply both sides of the equation by x, we'll have x is equal to, and you could say this distance here is y, but I'm going to keep it as the opposite for just a second before we plug in our numbers so we don't get confused on the math manipulation. And then we're dividing that by tangent of theta. So this is how we use this equation here to isolate and solve for x, which is the adjacent in this case. So now we need to figure out however many of these x's are. We're going to times that by, let's just say b for bounce, right? So the number of bounces times the distance x is going to equal 40 centimeters. And you could say L for the length of the tube. And so we have our expression here. These are all equal to each other, except that we need to, if we're going to multiply this side by b, we also need to multiply this side by b here, because these two have to equal the total tube length, which won't change in this case. So now we can use this, and we'll just take this portion right here. So we have b times the opposite, and that's all over tangent of theta, and that's equal to the length of the tube L. We're trying to solve for b though. That's what we need to see. How many times does the light bounce or reflect before it exits the tube, right? And so we need to isolate this. So let's now multiply both sides of the equation by tangent of theta, and then we'll divide by the opposite. So b is equal to L tangent theta over the opposite O. So now we can start plugging in values here. We know this angle here is the 60 degrees, and we know the opposite is the 8 times 10 to the negative 2 meters, or the 8 centimeters. So B is going to be, let's see, 40 centimeters, or 40 times 10 to the negative 2 meters, times tangent of the angle 60 degrees, and that's all divided by the opposite, which in this case here we said was 8 times 10 to the negative 2 meters. So when we come to our calculator now, we have 40 times 10 to the negative 2 times the tangent, times the tangent, there we are, of 60 degrees, and that's all divided by the opposite, which we said was 8 times 10 to the negative 2 meters, or 8 centimeters. So that gives us 8.66, and so we could round that to 8.7. 8.7 times it's going to bounce. But we don't count a 0.7 of a bounce, right? And so it's only going to bounce 8 times before it exits the tube. So if the tube was just a little bit longer, we could get a 9th, but it's not. And so we get 8 total bounces before it exits the tube.